Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture, we are going to learn about the classification of coordination complexes. In the previous lecture, we have learned that the chemical compounds which consist of anions or the neutral molecule which is bonded to the central metal atom or ion through covalent coordinate bond is known as a coordination compound or complex compound or simply the coordination complex. We have studied the different examples of the coordination compound or the complex compound in that lecture also. Now in today's lecture, we are going to learn the classification of these coordination complexes in detail. So let's get started with this video. Generally, the coordination complexes are classified on the basis of the two types. The first one is the types of the ligands that are attached to the central metal atom or the ion, while the second type is on the basis of the net charge on that complex compound. So now let us consider the first classification, that is the classification on the basis of the types of the ligands which is attached to the central metal atom or the ion. Now in this classification, generally the same type of the ligand or the different type of the ligands, they are attached to the central metal ion. Now in this classification, generally the coordination complexes are classified into the two types, that is the homoleptic complex and the heteroleptic complex. Now let us start with the first, that is homoleptic complex. The complexes in which the central metal atom or ion is bonded to the same type of a ligand or only one type of the ligand. Now these complexes are known as homoleptic complexes. Now here I have taken the first example, that is CONH3 6 times plus 3. Now this is actually the complex ion. In this complex ion, the 6 ammonia ligands are attached to the cobalt central metal atom. Hence there is only one type of ligand, that is ammonia, which is coordinated to the central metal atom. Hence this is the example of your homoleptic complex. So now let us consider the second type, that is the heteroleptic complexes. The complexes in which the central metal atom or ion is attached to different type of the ligands or more than one type of the ligands. Now these complexes are called as heteroleptic complexes. Now let us consider the example regarding this one. CONH3 4 times Cl2 plus. Now this is again a complex ion. Now in this complex ion, the 4 ammonia and the 2 chlorine, it is attached or it is coordinated to the central metal cobalt ion. Hence in this complex there is two different types of the ligand present, that is ammonia and chlorine. Hence this is the example of your heteroleptic complex. We know that homo means same and hetero means different. So generally in the homoleptic complex, the same type of the ligands attach to the central metal atom or ion, while in case of the heteroleptic complex, the different type of the ligands which is attached to the central metal atom or the ions. So this is the two classes on the basis of the types of the ligand which is attached to the central metal atom or the ion in the coordination complexes. Let's consider the second classification, that is the classification on the basis of the net charge on the coordination complexes. Generally these coordination complexes are classified into the three types, that is the cationic sphere complexes or simply the cationic complexes. Next, that is anionic sphere complexes or anionic complexes. Third, that is the neutral sphere complexes or simply the neutral complex. Let us consider the first type, that is the cationic sphere complexes or simply the cationic complexes. Complexes which having a positively charged coordination sphere is called as cationic sphere complexes or simply the cationic complexes. If we consider the example regarding this one, is in the coordination sphere Zn NH4 times 2. As this coordination sphere having the plus 2 charge, hence it is a cationic sphere complex. If we consider the second example here, that CONH3 5 times Cl SO4. Now this coordination complex after dissolving gives CO NH3 5 times Cl plus 2 complex ion plus SO4 2 minus ion. As these complex ion have the positively charged coordination sphere, hence it is also the example of your cationic complexes. The second type, that is the anionic sphere complexes, or simply the anionic complexes. The complexes which having the negatively charged coordination sphere are called as an anionic complexes. We know that anions are negatively charged species. If you consider the example regarding this one, NiCN4 2 minus ion, as this coordination sphere having the negative charge, hence it is the example of your anionic complex. Now if I consider the second example regarding this one, that is K3FeCN6. So this complex after dissolving gives the FeCN6 3 minus ion along with the 3 potassium ions. So as this complex ion have the negative charge, hence it is also the example of your anionic complex. Now the last category, that is the neutral complexes or neutral sphere complexes. The complexes which do not have any charge on the coordination sphere is called as a neutral complexes or neutral sphere complexes. Now if you consider the example regarding this one, PT-NH3 2 times Cl2, as this complex do not have any charge on the coordination sphere, hence it is the example of your neutral complex. Now let us consider the second example, that is NiCO4 times. So here again you can observe that in this coordination sphere there is no any charge, hence it is also the example of your neutral complex. So in today's lecture we have learned the classification of the coordination complexes on the basis of the two factors, that is the types of ligands, and the second one is the net charge on the complex ion. You like this video? Thank you so much for watching this video. See you in my next video.